In example 5, we need to find for what values of x is g of x, or the values of y, increasing or decreasing. We could also list any constant areas, although I'm not sure this one will have anything like that. So we can just go to our calculator and type the function in. Raise that to the third power, 9x squared. And we'll just take a look. I'll go zoom 6 here and see what this thing is looking like. Hope you can see that on the graph. Okay, so we've got a little bit of a wobble here and here. And what I need to do is kind of recenter this a little bit. So I'm going to zoom out. And you got to hit enter again there. And we'll see if that wobble shows up there. That wobble's kind of right in here. So I'm going to go zoom box. And this is kind of like click and drag here on an actual computer to select some material. And this just gives us a better look as to where this thing is at. And we'll see if that helps us. If not, we can do it again. We can re-zoom out and zoom back in. So it looks like this is a nice cubic function. It's not going to have any more turns than this. It's just going to have the 2 here. And what we need to do now is we need to look at this thing, and from the left it seems like we're increasing up to this point, then we're decreasing, then we're increasing again. So let me try to draw maybe a graph, and I'm only going to draw the x-axis here because that's all we really need. And so it looks like this graph kind of comes up, then comes back down, then comes up. So we really need to know these two positions right here, these two x values. To do that, we can use our calculator. We can go to second trace, which is the calculate menu, and we're going to use this function called find the maximum. See, the cursor is down here now. We're going to try to find the maximum here. That'll give us that x value. So we need to go anywhere to the left, hit enter, come back to the right, hit enter, and then come back to the middle somewhere. It just says guess. It doesn't have to be perfect. And then you're going to hit enter there. And you can see that this maximum is at, well, that's e to the negative 7, so that's very close to 0. And this one also is very close to 0. The e to the negative 13 means times 10 to the negative 13th power, which is pretty small. So this is going to be like negative 0.000000000000499. Please don't count the number of zeros to make sure that they are 13 or 12 as it is, okay? But it's going to be very close to 0. So the actual x value here, and we really don't care about the y value, I suppose. The actual x value here is 0. You can tell here that it'll hit the x-axis right at 0, 0 if you substitute that in, and I'm pretty sure that's the turning point here, okay? You could zoom in if you wanted and figure it out too. So we're now going to use our calculator to find the minimum. So we can go anywhere to the left, hit enter. Anywhere to the right of the minimum, we're concerned about this point, just follow the cursor and then hit enter. And the x value here is 1.9999998. Your calculator has a built-in error. It's actually 2. So you definitely want to understand that your calculator is not perfect, like you are, of course, and round that up to a 2 here. So this x value is 2. Now we know the x values, and we're just looking at the behavior of the function. And the behavior from negative infinity to 0 is it's increasing. So we're going to write our increasing like this, and it looks like we've got a decreasing and then another increasing portion. So our increasing is going to be negative infinity up to 0, and then we increase again from 2 to infinity. So we could write that now. We can write that now or later. It really doesn't matter. And then the decrease part is going to be just from 0 to 2, just over that x interval. Remember, we don't care about the y values when we're actually writing the increasing and decreasing intervals, because we know what the y values are doing. Here they're increasing. We don't need to state those y values. We want to state over what values of x is that function increasing. For the decreasing, though, it's just 0 to 2.